The Dyson Sphere. So you think your solar panels are hot stuff? That's cute. Now imagine a civilization so advanced, so utterly dominant over its cosmic environment that it decides its home star would be more useful if it were completely encased in a shell of solar collectors. That, in a nutshell, is a Dyson Sphere. Proposed by the brilliant and unnervingly forward-thinking physicist Freeman Dyson in 1960, this isn't just a structure, it's a statement. It's a civilization looking at its sun and saying, "I'll take all of that, thank you very much." A true Dyson sphere would be a solid shell of matter completely enclosing a star, capturing 100% of its energy output. The engineering challenges are, to put it mildly, biblical. You'd need more material than is available in our entire solar system. The gravitational stresses would be insane, and a single catastrophic failure could turn this stellar powerhouse into a star-sized shrapnel bomb. But the payoff? A nearly infinite supply of energy, enough to power a civilization for eons and fuel computational projects of unimaginable complexity. More likely, a civilization would build a Dyson swarm, a massive collection of individual solar-collecting satellites orbiting the star in a dense, overlapping formation. Think of it as a cosmic beehive, with each satellite sipping energy and beaming it back to a central point. This is far more feasible from an engineering standpoint, but the sheer scale is still enough to make your head spin. We're talking trillions of satellites, each one a technological marvel, all working in perfect harmony to create a stellar-sized power grid. How would we even detect such a thing? A complete Dyson sphere would be invisible in the visible light spectrum, but it would radiate immense amounts of infrared energy, waste heat from the civilization's activities. So if we ever point our telescopes at a star and see something that's blazing in infrared but eerily dark invisible light, we might just have found the ultimate alien megastructure. It would be the cosmic equivalent of finding a perfectly manicured lawn in the middle of a primordial jungle, a clear, unambiguous sign of intelligence. The ring world. If the Dyson sphere is the ultimate power plant, the ring world is the ultimate habitable real estate. Popularized by Larry Niven's science fiction masterpiece of the same name, a ring world is an artificial ring built around a star with the habitable surface on its inner side. Imagine a ribbon of land millions of miles wide, spinning to create artificial gravity, with a star at its center providing eternal daylight. We're not talking about a dinky little space station. We're talking about a structure with a surface area millions of times that of Earth. The scale of a ring world is almost impossible to comprehend. You could have entire oceans, mountain ranges, and continents laid out on its surface. The sky would be a continuous arc of land stretching from horizon to horizon, with the star a permanent fixture in the heavens. To create this cosmic ribbon, you'd need to dismantle entire planets, asteroids, and moons for raw materials. The engineering would require materials of impossible strength and manufacturing capabilities that border on magic. But the real genius of the ring world is its efficiency. Unlike a planet where only a fraction of the surface is habitable, a ring world offers a continuous, unbroken stretch of prime real estate. You can have countless ecosystems, support trillions of inhabitants, and still have room for a few national parks the size of Jupiter. The civilization that builds a ring world isn't just looking for a new home, it's looking to create a paradise of its own design, a custom-built world where the very laws of geography are under its complete control. Of course, living on a ring world would have its quirks. There's no day-night cycle unless you build massive shadow squares orbiting between the ring and the star. The weather would be a nightmare to control, and a single micrometeoroid impact could potentially destabilize the entire structure, sending trillions of souls hurtling into their sun. But for a civilization that has mastered the art of stellar engineering, these are probably just minor inconveniences on the path to creating a literal heaven in the cosmos. The Alderson disk. The Alderson disk is what happens when a ring world and a Dyson sphere have a baby, and that baby is an absolute monster. This is a truly bizarre and mind-bendingly large megastructure, a giant, flat disk with a star in the center. The habitable zone isn't on the edge of the disk, but in a massive ring-shaped area on its surface. Imagine a cosmic frisbee, trillions of miles in diameter, with a sun poking through the middle like a weird, fiery belly button. The sheer unadulterated absurdity of an Alderson disk is what makes it so compelling. The day and night cycle would be determined by the bobbing motion of the star within the central hole. The inner regions of the habitable zone would be a sweltering, eternal desert, while the outer regions would be a frozen Arctic wasteland. In between, you'd have a massive band of temperate, Earth-like terrain, a paradise of unimaginable proportions. The gravitational effects on an Alderson disk would be strange. Gravity would pull you down towards the center of the disk's mass, but also sideways towards the star in the middle. The result would be a world where level ground is a complex, constantly shifting concept. Oceans would slosh around in bizarre patterns, and mountains would have to be engineered with a kind of cosmic feng shui to avoid collapsing under their own weirdly angled weight. Why would anyone build such a thing? The answer is simple: surface area. An Alderson disk offers a truly staggering amount of living space, enough to make a ring world look like a cramped studio apartment. A civilization that builds an Alderson disk isn't just expanding, it's exploding. It's a civilization that has transcended the very concept of a home planet and has decided to turn its entire solar system into one single contiguous piece of real estate. It's the ultimate expression of cosmic manifest destiny, a monument to a species that looked at the void of space and saw a subdivision waiting to be built.
The Matryoshka brain. What if a civilization's ultimate goal isn't expansion, but computation? What if it decides that the most noble use of its star's energy is to power a computer of such complexity that it could simulate entire universes? That's the idea behind the Matryoshka brain, a megastructure that is less of a home and more of a godlike mind. Named after the Russian nesting dolls, a Matryoshka brain is a series of nested Dyson spheres, each one feeding off the waste heat of the one inside it. The innermost sphere would be at a blistering temperature, powering incredibly fast computations. The next sphere would be cooler, using the waste heat from the first to power its own slightly slower computations. This continues outwards, with each successive layer running cooler and slower, until the outermost sphere radiates waste heat at just a few degrees above absolute zero. The result is a computational engine of truly staggering power. A fully realized Matryoshka brain could perform calculations that would make our most powerful supercomputers look like abacuses. It could simulate the entire history of a galaxy, create artificial consciousnesses on a whim, and explore mathematical realms that are utterly beyond human comprehension. It would be less of a machine and more of a digital god, a being of pure thought existing on a stellar scale. A civilization that builds a Matryoshka brain would be a strange one indeed. It might have uploaded its entire population into this cosmic computer, abandoning the physical world for a simulated paradise. Or perhaps it's a civilization of machines, a silicon-based life form that sees the universe not as a place to live, but as a problem to be solved. Detecting a Matryoshka brain would be incredibly difficult. Like a Dyson sphere, it would be dark in the visible spectrum, but its infrared signature would be incredibly faint, barely distinguishable from the background radiation of the cosmos. It would be the ultimate stealth megastructure, a silent, thinking god hiding in plain sight. The stellar engine. Why settle for exploring the galaxy when you can take your entire solar system with you?
That's the audacious, gloriously insane idea behind the stellar engine, a megastructure designed to move a star and its accompanying planets through the cosmos. This isn't just space travel. This is stellar relocation, a cosmic road trip on an unimaginable scale. There are several theoretical designs for a stellar engine. The most famous is the Shkatov thruster, which is essentially a giant mirror placed on one side of a star. The radiation pressure from the star's own light pushes against the mirror, creating a tiny but constant thrust. Over millions of years, this gentle push can accelerate the entire solar system to a significant fraction of the speed of light. It's the ultimate in slow travel, a journey for a civilization that thinks in geological timescales. Another, more aggressive option is to build a massive fusion engine that uses the star's own matter as fuel. This would involve siphoning off vast quantities of hydrogen and helium from the star, feeding it into a colossal engine, and using the resulting plasma jet to propel the entire system forward. This is far more efficient than a Shkatov thruster, but it's also incredibly dangerous. A single miscalculation could turn your star into an unstable, sputtering mess, or worse, a supernova. The civilization that builds a stellar engine is a civilization with a plan. Perhaps they're fleeing a dying galaxy, or maybe they're on a multi-billion-year mission to explore the entire universe. They are a patient, far-sighted people, a species that has mastered the art of playing the long game. Finding a stellar engine would be a truly paradigm-shifting discovery. It would be like finding a car key in a fossil bed, an undeniable sign that someone, somewhere, is driving the very stars themselves.
The Shkatov thruster. Let's get a bit more specific on the stellar engine concept, because the Shkatov thruster is just too cool to lump in with the rest. Named after the Russian scientist Leonid Shkatov, this is elegance in its purest form. It's not about brute force, it's about cosmic jujitsu, using the star's own power against itself. Imagine a colossal arc-shaped mirror so vast that it dwarfs the star it orbits. This isn't a simple flat mirror, it's a statite, a static satellite that uses light pressure to hold its position. The mirror is positioned in a polar orbit, hovering over one of the star's poles like a giant reflective halo. Here's where the magic happens. The photons streaming from the star hit the mirror and are reflected. This reflection imparts a tiny amount of momentum, pushing the mirror away from the star. But because the mirror is so massive, it's gravitationally bound to the star. The result is a delicate balancing act, a cosmic dance between light and gravity. But the real trick is what happens to the star itself. By reflecting a significant portion of the star's light in one direction, the Shkatov thruster creates an imbalance in the star's radiation pressure. The star is now pushing itself using its own light as a propellant. The thrust is minuscule, but it's constant. And over millions of years, it adds up. The entire solar system begins to move, slowly but surely, through the void.
The Bishop Ring. If a ring world is a sprawling, cottonhead-sized metropolis, a Bishop Ring is a cozy, self-contained neighborhood. Proposed by the brilliant Forrest Bishop of the Institute of Atomic Scale Engineering, this is a more modest take on the rotating habitat concept. A megastructure that's still mind-bogglingly huge by human standards, but almost quaint in the context of alien super-engineering. A Bishop Ring is a rotating torus or donut of carbon nanotubes, about 1,000 kilometers in radius. It would be large enough to have a habitable interior surface with its own atmosphere and ecosystem. Unlike a ring world, which needs a star at its center, a Bishop Ring could be built in deep space or in orbit around a planet. It's the ultimate in off-grid living, a self-sufficient world that can be placed wherever you want it. The real genius of the Bishop Ring is its practicality. It's on the very edge of what's possible with known physics and materials. We could, in theory, build a Bishop Ring with today's technology if we had a few centuries and a truly obscene amount of money. It's a stepping stone, a starter megastructure for a civilization that's just beginning to dip its toes into the cosmic engineering pool. But don't let its relatively small size fool you. A single bishop ring could have a surface area of thousands of square miles, enough to support a population of millions. And because they're self-contained, you could build them in vast clusters, creating a sprawling, interconnected civilization of artificial worlds. It's a vision of a future where humanity, or some other enterprising species, has broken free from the shackles of a home planet and has begun to build its own worlds, one cozy cosmic cul-de-sac at a time. Orbital rings. Getting into space is hard. You have to fight against gravity every step of the way, burning massive amounts of fuel just to reach orbit. But what if you could build a highway to the heavens, a structure that makes space travel as easy as taking an elevator? That's the idea behind the orbital ring, a megastructure that would revolutionize our relationship with space. An orbital ring is a massive, spinning ring placed in a low orbit around a planet. It rotates at a speed slightly higher than orbital velocity, so it's constantly trying to fly off into space. This outward force is counteracted by a series of tethers, or cables, that connect the ring to the ground. The result is a stable, stationary structure that encircles the entire planet. From this ring, you could build spokes that extend down to the surface, creating a series of space elevators. You could ride a magnetically levitated car from the ground to the ring in a matter of hours. No rockets required. The ring itself could be a massive, habitable structure, a city in the sky with breathtaking views of the planet below. It would be the ultimate transportation hub, a gateway to the solar system and beyond. The construction of an orbital ring would be the largest engineering project in human history, but it's not impossible. It would require a massive amount of material, but it could be built with existing technologies. It's a project that is tantalizingly within our grasp, a glimpse of a future where the sky is no longer the limit, but the beginning of a new frontier. Topopolis. A topopolis is what happens when you take the concept of a rotating habitat and stretch it to its most absurd, noodle-like conclusion. It's a long, thin tube of habitable space looped around a star multiple times, like a cosmic strand of spaghetti. The tube would rotate to create artificial gravity, and the interior would be a continuous, world-spanning landscape. Imagine living in a world that is, for all intents and purposes, infinite. You could walk in one direction forever and never reach the end. The sky would be the other side of the tube, a continuous curving vista of land and cities. The sun would be a distant, brilliant point of light. Its position in the sky would be determined by which loop of the spaghetti you happen to be on. A topopolis is a truly bizarre concept, a megastructure that seems to defy all common sense. But it has one major advantage: it's incredibly stable. Unlike a ring world, which is constantly in danger of collapsing, a topopolis is held together by its own internal tension. It's a strong, resilient structure, a cosmic noodle that can withstand the rigors of stellar engineering. A civilization that builds a topopolis is a civilization that values stability and longevity above all else. They are a patient, methodical people, a species that is willing to build a truly strange and wonderful home for themselves as long as it's a home that'll last for eons. The Kardashev scale isn't a single megastructure, but a way of classifying civilizations based on their energy consumption. Proposed by the Soviet astronomer Nikolai Kardashev in 1964, it's a cosmic measuring stick, a way of ranking species on their journey from planetary obscurity to galactic domination. A Type 1 civilization is a planetary one, a species that has mastered the art of harnessing all the energy that reaches its own planet. We are currently a Type 0.7 civilization, still a few centuries away from reaching this milestone. A Type 1 civilization would have complete control over its planet's weather, geology, and biosphere. It would be a true master of its own world. A Type 2 civilization is a stellar one, a species that has learned to harness the entire energy output of its own star. This is the realm of the Dyson Sphere, the ring world, and the Matryoshka brain. A Type 2 civilization would be a true cosmic power, a species that can reshape its solar system to suit its needs. A Type 3 civilization is a galactic one, a species that has harnessed the energy of its entire galaxy. We're talking about a civilization that has colonized billions of star systems, built megastructures on an unimaginable scale, and has perhaps even learned to manipulate the fabric of space-time itself. A Type 3 civilization would be indistinguishable from a god. The Kardashev scale is a sobering reminder of just how far we have to go, but it's also a source of incredible inspiration. It's a roadmap to the future, a blueprint for a destiny that is written in the stars. It's a challenge to our species, a call to reach for the heavens and claim our place among the cosmic gods.